Hello and welcome back to this course, covering the exam topics for the JNCIS-SP certification. In this section of the course, we're reviewing Layer 2 switching and VLANs, where we're covering Layer 2 switching mechanisms and Ethernet switching configurations in Junos. In this video, we'll be covering Layer 2 troubleshooting and maintenance task workflows, and common commands used for gathering information and performing troubleshooting. Up until now, in this course, we've been doing a lot of theoretical review, and haven't gotten yet into any practical application at the command line. In this lesson, that changes. Here, we'll cover how to configure the management interface on an EX switch, how to enable Ethernet switching on a Junos interface, collect interface status information and bridging table information, clear the bridging table when troubleshooting, and defining static entries if needed. Let's jump in and take a look at the out-of-band management interfaces on an EX switch. The EX switching platform contains an out-of-band management interface, typically very close to the serial console management interface, physically. As we can see here, the out-of-band management interface is labeled on the chassis as the MGMT interface, and is physically located directly above the serial console interface. The out-of-band management interface can be very useful in environments where you truly have an out-of-band management network that is physically separate from the production environment. In this configuration snippet, we see how to configure the management interface with an IP address. The interface is configured like any other interface in Junos, though this interface's name is ME0, and the IP is being configured on Unit 0. By default, the production interfaces on an EX switch are configured to be switch ports, and the Ethernet switching family configured. However, you may encounter a situation where you need to reconfigure an interface, or group of interfaces, to be switch ports again. So let's review how to accomplish that next. On Junos devices, the Ethernet switching family must be configured on a logical interface to enable bridging. This protocol family will allow the interface to be configured as a member of VLANs, and for the port to participate in the bridging mechanisms. This configuration snippet shows how to configure the Ethernet switching family. Notice that the family configuration is under the logical unit hierarchy and not the physical interface. If you have many interfaces that need identical configuration, as is common for switches, then an interface range may be used. This configuration example here shows how to configure an interface range. In the interfaces hierarchy, we specify the interface range configuration command and give the range a name. The interfaces are added as members of the interface range by specifying them like here. Within the interface range configuration, any configuration options that are typically available at the physical interface hierarchy are available. Here, we are simply configuring the Ethernet switching under logical unit 0. Now that we've configured some interfaces as switch ports, let's see how to validate that they are indeed functioning as switch ports. Using the show interfaces terse operational mode command, we can see the protocols running on a logical interface. The Ethernet switching protocol is abbreviated as ETH switch, as shown in this output here. This indicates that the logical interface is configured as a switch port with the family Ethernet switching command configured. Since we've confirmed that the configured interfaces are indeed participating in bridging, Let's check the bridging table to confirm that we're learning any MAC addresses on those interfaces. We use the Show Ethernet Switching Table operational mode command to view the contents of the bridging table. As we see up here, there should be 3 devices connected to our switch on GE001, 2, and 3. When reviewing the output of our command at the bottom, we see each of these 3 devices are successfully being learned. Let's take a closer look at this output. In the far left column, we see the VLAN that these MACs are seen on. This switch only has the default VLAN configured. The next column shows the MAC address in the table entry. The next is any flags for this entry. D means the entry was learned dynamically. An S would mean that the entry was statically configured. The age column would show how long it has been in seconds since the last frame sourcing from that MAC address has been seen. In this case, all 3 devices are actively transmitting, so not enough time has passed since the last frame has been seen for the switch to display a number, which is normal. Finally, on the right, we see the logical interface for the bridge table entry that the MAC was seen on. We see that the MACs were learned on the 3 interfaces that we expect. The bridging table contains the information learned both from traffic seen on the network and from entries configured by the network administrator. Junos uses this information to then build the forwarding table that is then programmed to the PFE to allow for frame forwarding. Let's take a look at that table next. The forwarding table is not just used for bridging. It is also used to store information to forward routed packets. There is, however, a section of the forwarding table dedicated to Ethernet switching. To view the forwarding table for Ethernet switching, we use the Show Route Forwarding Table Family Ethernet Switching operational mode command. In the example output below, we have 2 bridging tables on this switch, one for the default VLAN and another for V950 VLAN. This output is rarely needed and generally would only be used in a circumstance where the switch's behavior when forwarding frames does not match what is expected, given the information in the bridging table. We only have 2 entries in the forwarding table here, under VLAN 950. These are unicast entries and learned on GE000 and GE001. Now that we know how to collect information from our switches, let's take a look at how to clear the bridging table before we review how to define a static entry in the bridging table. Several situations can be encountered that require clearing the bridging table. Perhaps you want to test the switch is learning a MAC appropriately and don't want to wait the default 5 minutes for the existing entry to expire. Perhaps the switch is encountering a software bug and not forwarding frames appropriately, and a quick clearing of the table will reset the Ethernet switching forwarding state. The bridging table can be cleared as a whole, for a single VLAN, or for a single interface. Here, we demonstrate clearing the bridging table entries for a particular interface. First, we see the 2 entries in the bridging table, one on GE000 and the other on GE001. We issue the clear Ethernet switch table interface GE001 command and take a look at the bridging table once again. We see that the entry for GE001 has been removed, as it was administratively deleted from our bridging table. This can be a powerful troubleshooting tool, however, should also be done with care. Recall how a switch handles traffic when the destination MAC address does not have an entry in the bridging or forwarding table. The flooding mechanism is used to flood the frame out all interfaces in the broadcast domain to ensure the frame is forwarded to the destination. So, once we clear this entry, all frames destined for that MAC address will be flooded until a response sourcing from that device is seen to allow the switch to create a new, dynamically learned entry in the bridging table. What can we do, though, if we have a device which we expect will not respond often, or perhaps ever? There are other situations as well which can justify the creation of a static entry in the bridging table. So let's take a look at how to create those entries next. A static bridging table entry is created using the static MAC configuration command under the logical interface of the switch options in the VLAN's configuration hierarchy. In the configuration snippet, here, we're in the Edit VLANs hierarchy, and then in the VLAN named V950, and the switch options, we enter the logical interface we want to create a static bridging table entry for, and enter the static MAC command along with the MAC address for the bridging table entry. Below, we have a sample output reflecting the static entry in the bridging table. We see that the flags column has an S for the static entry we just created. I appreciate you working through this lesson with me. I hope that this lesson has been informative for you, and I would like to thank you for viewing.